So, welcome student to the course of Fundamental of Classical Electrodynamics. So, today we will have lecture 3 and we will continue with the use of this Levi-Civita symbol that we defined in the last class and try to understand few coordinate system. So, today we have lecture 3 or class number 3. So, if you remember last day we defined a symbol which we call Levi-Civita symbol, which is having either value 1, -1 or 0. When we have a cyclic order of x, y, z, then this value is 1. When we had the opposite order, if I say this is 1, this is 2, this is 3. So, it should be a right handed order, and similarly if it is 1, 2 and 3, it is the left handed order. For this case it was 1, this case it was -1, and all other cases this value is 0. So, this corresponds to this orientation, this corresponds to this orientation, and otherwise this value gives us 0. Also we defined this delta function, Kronecker delta rather, which is equal to 1 when I is not equal to j, when I is equal to j, I is equal to j, and equal to 0 when I is not equal to j. So, these were two systems, delta and two symbols that we define in this way, and then we did something. So, today we will going to use these symbols in order to understand few vector properties. So, let us start with this well known scalar triple product. In scalar triple product, we know one very well known identity, that if A, B, C 3 vectors are there, then A dot B cross C, it is equal to B dot C cross A, and that is equal to C dot A cross B. So, this identity one can prove easily with using these Levi-Civita symbols. So, what is the meaning of A dot B cross C? This is nothing but A x, A y, A z, B x, B y, B z, and C x, C y, C z. So, that is by definition. Now, the next is to understand using this Levi-Civita symbol how to execute, how to prove that A dot B cross C is equal to B dot C cross A is equal to C dot A cross B. A dot B cross C this is a dot product. You can see this is a vector, and we know that this dot product can be represented like ai and whatever the vector we have b cross c and then I. This is the way we define, right. Now, if I expand this, so this is ai, and last day we mentioned that if two vector a cross b is there, then in terms of Levi-Civita symbol, the ith component will be epsilon I j k b j c k. This is the way we can write this. Now, I manipulate this, I write epsilon I j k because I am now dealing with the components. I put this a inside a, I and then b j and c k. The next thing is I just rearrange few things. Let us put this b j here, because I need what I at the end of the day I need to prove that this quantity is equal to b dot c cross a. So, using the Levi-Civita symbol, so this b is sitting here. So, that is why I write b here. I just replace this and rearrange, and then c cross a. So, I just put c k here and a here. I just change the order. The next thing is very important, and that is I now make this, because according to our notation, if I have I and I here, then it is I, then epsilon I j k j k. So, let us make these things I, these things as j, and these things at k. By doing that, I just change the the name of this symbol. By doing that, I need to change this also in the epsilon, and the epsilon now I become k, and then j become I, and k become j, and this now I write b j c k b I, because I now change this b I c j and a k. Okay. So, these things I now rearrange. I write b I and then epsilon whatever I am having k I j, then c j a k. Now, I can rearrange this, because the thing that you need to understand that epsilon I j k is equal to epsilon, if I consider the order, j k I is equal to epsilon k I j, and these values are 1. So, that means I can write this as b I epsilon k I j, this one I just replaced epsilon I j k, because both the things are 1, and then c j, then sorry, here it is a multiplication, c j a k. So, this quantity eventually gives us b I, and this section is given us, this part is given us c cross a with the ith component, and which is the thing that I wanted to prove here, because a dot b cross a I wanted to prove b dot c cross a. So, ith component here, so this is nothing but B dot C cross A. So, I prove this identity just by using this Levi-Civita symbol. That is why it is very, very powerful and very, very interesting. Similarly, you can also prove, you can also similarly prove that A dot B cross C is equal to C dot A cross B. So, I request the student to have a look and please try to prove this. I already prove that A dot B cross C is B dot C cross A. So, you can also prove that A dot B cross C is equal to C dot A cross B in the same, using the same process, same methodology. Well, now we move forward and now we understand what happened for a little bit complicated case, and that is the vector triple product. For vector triple product, we have a very interesting identity A cross B cross C is equal to B and then C A minus C A B. So, you can see that in the left hand side it is A cross B cross C. So, eventually this is a vector quantity. Right hand side, if you look, C dot A is a scalar, but it is multiplied with the vector V, and A dot B is a scalar which is multiplied with the vector C. So, the right hand side is also a vector quantity, which should be. Now, these things we are going to prove, but before that I like to introduce a very, very important identity. You must remember this identity, very, very useful identity, and that is epsilon I j k multiplied by epsilon I L m, that is equivalent to so delta of J L, then delta of K m minus delta of J m and then delta of K L. So, you need to be careful enough here, but there is a simple way to remember, the way I remember it. So, this is I here, I here. So, in the right hand side it should not be any I. So, when I is sitting in the front, right hand side, you should not have any kind of I, because I am dealing with the ith component here. Then JL, JK sitting here and LM sitting here. So, the first term is the closer one, JL, JL, and then next KM, KM. This pair will be put like this. This order will be like that: J first, then L first. So, JL, K second, M second, then KM. Now, I reverse the order, and in order to reverse the order there will be negative sign. You just remember in this way. So, now you can see that J is here and then the M I now use. So, M, it is not L, previously it was L, now M. Then K is here and the closer one L is. So, now I change the order, and when I change the order there is a negative sign. You just remember in this way and it should be useful. This identity is very useful in understanding different complicated vector identities. So, I request the student to have a look and see it. So, epsilon I j k, epsilon I L m, what is this? Delta J L, J is sitting here, L is sitting here, the first So, I will put it, then k is sitting here, m is sitting here. In the second I put it. Now, I change the order. So, when I change the order, there should be a negative sign. Now, j is first, m is second, I put j first, m second, and then k second, L first. So, I put k and L, that is all. Well, I am going to use this to prove this vector identity. So, now what is this quantity? Let us quickly understand this delta. So, delta, you know, JL delta Km, this should be 1 when K is equal to M and J is equal to L. This is only condition when this is 1, otherwise it will be 0. Similarly, delta Jm delta KL, this is 1 when M is equal to say J and K is equal to L. This is the condition for making it 1, this is the condition for making it 1. So, we have to be careful with this which is related to the delta function. Now, I am going to use this. I am going to use this. How I use? Let us check. So, I am having A cross B cross C, and I need to show in the right hand side that B C dot A minus C A dot B. So, like the way we did in the previous case, so A cross B cross C, if I want to find out the ith component of this vector quantity, it will be simply epsilon I j k A j, and whatever I have here this vector quantity B cross C, the kth component of that, okay, because A dot A cross B is epsilon I j k A j B k. So, in place of B I have another vector B cross C. So, I will just use this expression the way I write A cross B. Now, again one A cross B is B cross C, the kth component sitting here. So, that I need to resolve. So, now I have epsilon I j k and then A j, and this quantity I need to write that epsilon k, and then I need to use another indices Lm because it is another, and then B L C M. Okay. Now, I put all the epsilon together, epsilon I j k epsilon k L M, and then I write A j B L C M. Now, you can see that I am having a quantity this epsilon I j k epsilon k L M, which I already defined here, epsilon I j k L multiplied by epsilon I L M, but here you can see that it is I j k and k L M. So, here it is I is sitting here, but here you can see that k, which is a common term, sitting here and here. So, I need to I need to make it symmetric. So, I write this term, I write epsilon k I j and epsilon k L M, and the rest of the term is as usual, it is A j B L and C M. So, you can see that here I am making a note that epsilon I j k is same as epsilon k I j by cyclic rule. Okay. Now, this quantity, once I get this quantity, now I am in a position to expand this the way I expanded, because I know that this is the rule of this. So, I will going to expand this, and it should be it should be delta I, because it is the kth is here. So, I L then delta j m minus delta I m delta j L and the rest of the term. Now, this quantity everything is changing. So, I need to understand, we need to understand that when it is. So, when I is equal to L, then and when j is equal to m or m is equal to j. So, the first term I can write is a j, m where it is there I need to put it as j. So, b l is there. So, it should be b I, because when L equal to I, then it is a meaningful, and I have C M is there. So, it should be equal to J, then only it is a meaningful. So, I have A J B I C J. In a similar way, the next term, when I is equal to M, then it is a meaningful thing. So, C I can write it like C I, and then A j is there. So, j let us put j here, L I now need to put like B j. Okay. Now, here you can see that I am having j here and also I am having j here. So, I can write it like B I, this quantity I write B I, and in the bracket A j C j minus C I can write in the bracket A j B j. Now, this quantity A j C j is nothing but A dot C, because if you expand A dot C by using the Einstein notation, it should be simply A j C j. In a similar way, A dot B is nothing, A j B j is nothing like A dot B. So, I can write it like this is a vector B, and then the ith component of that quantity and minus. Now, I am having another term. So, I can write it as C vector and B dot A or A dot B. This is the ith component. So, this is the thing actually I wanted to prove. You can see that A dot B, A cross B cross C is B C A minus C A B. So, okay, here is a line, I do not know from where this line came. So, let me erase this. Okay. So, B C A minus C A B. So, we prove this A dot B and B dot A are same. So, here you can see that B C A minus C A B. Okay. So, this is the way by using the Levi-Civita symbol you can prove the different identities, vector identities, and you find that it is very useful, and I request you to please note this identity which is in this red box. This is a very useful identity, and in future we will going to use this. Okay. After that, let me now quickly jump to the next very important topic, and that is the coordinate transformation. We have a preliminary idea about the vector operation, vector, and how using the delta function and Levi-Civita symbol we can play with these vector identities. Later we will going to prove more and more vector identities again by using this Levi-Civita symbol, but I request you to practice. There were couple of problems given to you, so I believe you are practicing them. But now let us jump to the new topic, which is the coordinate system. So coordinate system and transformation. Okay. So, coordinate system and transformation. So, let us start with the most useful or most well known coordinate system, which is the Cartesian coordinate system. Cartesian coordinate. For Cartesian coordinate, we have these are the x, y, z, they are perpendicular to each other, and any point here P, which is a function of x, y and z, and we can have this point by simply calculating the x point and then y point and the z point. This is the way we calculate. So, what is the restrictions of this coordinate system? So, the restriction is x is in between this, y is in between minus infinity to the plus infinity, and z lies in this range. These are the range of the coordinate points x, y, z. A vector. Now, if I want to define a vector in this coordinate system, say vector A, that is Ax I unit vector plus Ay j unit vector plus Az k unit vector, and I j k also follows certain rule, and that is I dot I equal to j dot j equal to k dot k is equal to 1, and I dot j equal to j dot k equal to k dot I is equal to 0. Orthonormal, they are orthonormal basis, they are forming orthonormal basis. Not only that, I cross j is equal to k, and then j cross k equal to I, and k cross ijk, jki, and then ki, it should be j. They are forming the cyclic thing. I cross j, it should be k, k cross I, it should be j, and then I cross j, it should be k, j cross k it should be I, and k cross I it should be j. Well, after that we have a coordinate system which is the cylindrical coordinate system, very very important in electrostatics, and this is the next coordinate system is normally we call it a rho phi z coordinate system. In rho phi z coordinate system, if I want to define a point, I have x here, not x, now we are not dealing with so I should not write it x y z, rather I just make it like this, and then so a point here should be like over a cylinder. So I will have a cylindrical shape here first, okay. Now I define the point here, this is the point say, and this point if I make a perpendicular here, so this is my rho, making an angle phi here, and this from here it is parallel. So this is my rho, it is along this direction I have rho unit vector, and this is the value of the rho, this is the phi, and this length is z, from here to here this length is z. So if I now define the unit vectors, so z will be as usual in this direction, this is the unit vector z, this is rho, and phi will be along this tangential direction. So this will be my phi unit vector. The point here P should be defined with these three coordinates, that is rho from here to here, and then phi the angle rho is making, and the length from here to here z. So any point in space can be defined by these three parameter rho phi z. Now quickly try to understand that what is the range of this, the way we did previously. So rho rho less than infinity and greater than equal to 0, phi it should be less than 2 pi and it are equal to 0, and z it should be in between the infinity and minus infinity like before. So these are the ranges that we have for the coordinate system, this Cartesian coordinate system. Well, the vector, quickly I define the vector, how you write this vector A. So A vector can be written as the component A rho, rho unit vector, plus A phi, phi unit vector, plus A z, z unit vector. Now the same vector I defined previously in a different way, Ax I, Ay j, Az k, and the same again the same vector say A I can define in this. Note that the bases are now changed. Not only that, based on the change basis, we also have to change the this component A rho, A phi, Az, but at the end of the day we are defining the same vector. Now what is the relationship between these the unit vectors that we are having here? So let us try to quickly write it, the properties. So here, so rho dot rho is equal to phi unit vector dot phi unit vector is equal to z unit vector dot z unit vector is equal to 1. Similarly, rho dot phi is equal to phi dot j, that is equal to z dot rho is 0. That means they are forming a orthonormal basis. Not only that, this is a right hand system. So, rho cross phi give you z, phi cross z give you rho, and z cross rho give you phi unit vector. So, this is a right hand orthonormal, they are forming right hand orthonormal basis. So, today I do not have that much of time. So, I will in the next class I will okay, before concluding the class, let me at least write the transformation, the relation between x, y, z, and because that is related to this. So, the relationship between the coordinate system x, y, z and rho phi z. What is the relation? The relation, if you most of the student I believe they are aware of that x, y, z can be represented to rho phi z with a relationship, and the relationship I am writing here. So, rho is equal to x square plus y square whole to the power half. Phi is tan inverse of y by x and z is z. This is the relationship. So, left hand side we have rho and right hand side we have x, y, z. So, if the x, y, z is given to you of a point, you can find out what should be the value of the rho phi z in cylindrical coordinate system. In the similar way, I can have a reverse relationship, and that is x is equal to rho of cos phi, y is equal to rho of sin phi, and z is equal to z. So, that is quite trivial. I mean, if you just look in this coordinate system, what is the value of the rho if this is x, y, z, the line I am drawing here, if I am putting x, y, z here, then you can find out, and this point is also defined to x, y, z, then you know what is the relationship between the x, y, z point and rho phi z point. If rho phi z is given, you can calculate the x, y, z. If x, y, z is given, you can calculate the rho phi z, and these are the relationship they will follow, and this is quite trivial. If you know the rho, then you will find what is the value of x, what is the value of y. Rho is cos phi, so you will find the x value, rho sin phi, you will get the y value, and z is z. So, very trivial relationship they are following, and from that also you can find out that what is the value of rho phi z if x, y, z is given. So, with this note, I am not having much time today. So, I like to conclude here, and see you in the next class, where we will extend more and try to find out the relationship between the unit vectors. So, now we are having the relationship between the x, y, z coordinate point to rho phi z coordinate point. Now, the unit vector is also related. If I know I, j, k, how should I know the unit vector rho, phi and z? Okay. With this note, let me conclude. So, thank you for your attention. See you in the next class.